Hey y'all! Well, time for another sound room update, and today we're going to talk about the online websites and calculators and stuff that I've been playing around with, and just kind of show y'all what these different wall construction systems look like, what my options might be on drywall. I still haven't done pricing on these different products. I gotta weigh the ease of installation versus, how much the products cost and that sort of thing, and what the labor would be to use this versus that. That's all going to be, they call value engineer this to make sure that I'm getting as much as I can and the highest likelihood of success, because I don't want to have something that's so weird and hard to install, even if it's higher performing, that's not going to get installed right. So anyway, let's jump online and let me show you some of this stuff. So let's look at a few of these different systems you could use for building these isolation walls for a listening room. And this one's one that we saw with Jay used on his system or his room, and Robert Haley also used it with his listening room. And I'll put links to these videos below. Here's Robert talking about his room, and then this was Jay's room. And in this video specifically, I realized how complicated this system is to install compared to some of the other options. And I'm not saying this isn't a good system, but my concern is with the type of wall construction that I'm using, plus trying to get a contractor to understand what this is, because this isn't how they normally are used to installing drywall, that I think this could be very confusing and you could end up with a problem. So here's some of the details showing it. You basically put these strips along the walls, and then you hang the sheetrock, and then you put these little squares on the sheetrock, and then put the second layer of sheetrock up. And this is showing how you caulk around, and you have like this felt strip that goes around the, or not felt, but it's some kind of resilient dampening material strip that goes around the perimeter of all the walls, and then these channels go in between. So let's go to the installation instructions, and I think you'll see more what I'm talking about here. So this is something I'm not real crazy about. If you look at how the perimeter of the wall is attached to the stud, the screw goes through the first layer and the second layer, and yes, there's this gasket, but the sound can transmit through this screw from the sheetrock to the stud wall around the whole perimeter of the wall. And that just seems kind of problematic. The other issue that I'm not super crazy about is it's got this Z-shaped channel that this end's just loose. And then it's got a rubber strip here. Now they're not showing it in this side view, but there's also these little rubber pads that you got to put on the studs behind this piece of metal here. But again, you've got rubber between the metal and the stud, but then the screw is touching the metal into the stud. And to me, that doesn't seem like it's doing a lot of isolation. If you look at the path here, the screw goes into the metal and then goes through this metal and then the screw, and like I said, there's a rubber strip here. But the way these screws are done, it's mechanically connected to the wall through the screws. Now I know this is supposed to be a resilient channel that flexes and absorbs some of the dampening. But honestly, guys, I don't see what these rubber strips are doing if the screws are going directly from the sheetrock into the metal. And then they've got these rubber squares that go between the two layers of sheetrock. And that makes sense that you're giving that constrained layer dampening and an air gap between the two sheets to help absorb the resonant frequency of the wall. But yeah, I'm not super crazy about this. And it just seems really complicated. You have to put this perimeter gasket around the wall. Then you got to put these every 12 inches. Okay? And then they all have this splice thing, but on this it's required that you splice the channels over the joist. And then on the ceiling, they're showing, how to do the same perimeter gasket thing, but you got to put panel adhesive on the perimeter gasket because, of course, gravity is going to try to make it fall. They're talking about the same thing on the little squares here on the ceiling that they have a tendency to fall off while you're trying to put the next sheet of plywood up. And the other thing they talk about is if there's any dust, that this adhesive won't stick. And if you guys have ever worked with drywall, there's dust everywhere. I mean, even before you start mudding and sanding, just the sheets themselves have dust on them. So you could be like wiping off all the sheets before you try to put these little rubber pads on. And like I said, I'm not sure why they don't show it here, but if we go back to the other page, I think it shows, yeah, you can see the little rubber pads here that are on the studs. And Jay's contractor said he was having a hard time getting these things to stay stuck to the wood. And he was having to like put staples in them. And if somebody puts a staple in the wrong place, then the metal strips connected to the stud wall through the staple. And so that seemed just like there's so many errors that you could make. And even here they're showing how, if you got a drywall screw that goes through this stuff and hits a stud, that totally screws up the whole system. Other thing is, it's really expensive. I put in my basic guesstimate of what the wall sizes were going to be with a single door, and you're going to end up with $6,000 worth of sealants and felts and all these. I mean, just the wall pad squares are $2,000. And then the strips that go around the perimeter of the walls, almost $1,200. So, yeah, that's a lot of money to spend on a wall system. And that's not including the sheetrock or any of the other materials. So, here's the system that my sound guys recommended that I look at or use. And they're designing the room assuming we're going to be using this system. And this is Kinetics noise control, their IsoMax clips. On this one, there's an aluminum hat channel that fits in this slot here. And you can see the way this thing is designed. It totally isolates this hat channel from the stud wall using this style clip. And let me go to the instruction page. So they show two different kinds of hat channels. Here's a taller one, or they call it a furring channel, but most people call it a hat channel. And they've got a shorter one here that gives a lower stack height, which is what I'm probably going to go with because I think it would have less leverage on these clips if I'm going to be putting a lot of mass in the wall. it's more in shear, and this would give some leverage to pull on the clip. And so, I mean, these are more idiot proof, but if I mark where the studs are, I think these will work fine. So in this system, you just have the clips. You've got this resilient wall strip that goes on the floor to hold the wall off of the floor. And then you get these furring channels. So on this one, you can install these strips 24 inches on center instead of 1 foot on center. And they're showing the maximum distance between the clips is 48 inches. Because we're going to be using a heavier than normal wall, probably going to be installing them on 36-inch centers or something like that, like every other stud instead of every third stud. And again, you have the strip down here along the bottom, and you have the strip along the top here, and you don't need like that perimeter gasket that they were showing in that other system. And basically, you just want to make sure you get them level. You put however many clips you're going to need for that stretch of furring strip, and then you attach it on one end and then the other, making sure it's level. And if you overlap, you just overlap the channel between the studs and put like 4 screws in it to really make it a solid connection. And again, this just seems like a much easier to install system, and it looks to me like the wall is completely floating in rubber, and there's no mechanical connection whatsoever between the wall and this furring strip or this hat channel and the stud wall. The screws don't go directly from the sheetrock into the studs ever. And this is just talking about the load specifications for the clips, and that's one of the things that the sound engineer guys, as part of their fee, they're going to be calculating up, like probably going to be using this heavier gauge steel furring channel. I think earlier I said it was aluminum. They're made out of steel. And they're going to tell me how many clips I need to get. And looking at just some online suggestions, and actually ask AI, like, how many of these clips do they think I'm going to need? And I think it's going to be at the most like 5 boxes, and they're $500 a box. So for $2,500, I can get enough clips to do all the walls and the ceiling. And I haven't priced these furring channels, but I can't imagine they're very expensive. I think most of the expense is going to be on the isolation products, which are going to be these clips. And then no matter which system you use, you still have to have like the acoustic sealant to put around the gaps. So anyway, this is what I think I'm going to go with. And then the last one I wanted to show you is there's another type of isolation clip that uses those furring channels, and it looks like this. And the furring channel attaches onto it like this. And so the way these work is you put a screw with a washer through the middle of this clip into the stud, and then you like flex the furring channel into these little clips, so it looks like that, and then you attach the wall to this, and you can see the stack height on this is a lot taller, and so you're going to lose that much interior room with just this clip system. The other thing that I don't like is that you have this metal to metal connection, that the only thing that's holding them in place is the springiness of this. And if the installer got a little too aggressive on squeezing this channel to get it in there, it might not have a lot of tension. And I've read that these can rattle. And I can't imagine how annoying that would be to get this room done and there was a rattle in one of the walls and trying to figure out where it was and having to demo all that wall stuff to get to this thing to fix it. And so, yeah, that's not something I want to do. So the other thing that I'm not sure about yet is whether we're going to be using any kind of constrained layer dampening for the wall between the layers. And what they initially pitched to me was using a 4-layer wall with concrete backer board, then 5/8 sheetrock, then 1/4-inch plywood or 1/2-inch plywood, and then 5/8 sheetrock on top of that. And that would exponentially increase the number of clips you need and the labor that it would take to build the wall. But they did show me the difference in the resonant frequency of the different constructions. And that's the frequency that the wall itself gets excited at. And so the 2-layer sheetrock deal has a resonant frequency of 60 hertz, which is absolutely in the audible range with any kind of speakers. And they said that this 4-layer wall that they were looking at using was at 30 hertz. And what I'm asking them to go back and calculate as a compromise is a 3-layer wall starting with concrete backer board, then a layer of plywood, and then put the sheetrock on top of that. And there's a couple of advantages to doing that. Having 3 different density materials helps reduce the resonant frequency because sound doesn't like the interface between 2 different densities of solid material. And so it's going to be way better than 2 layers of sheetrock, while still not making the clips get overloaded where I would need like $4,000 or $5,000 worth of clips. And so they're working on the calculations on that. That's kind of what I'm leaning towards. It also gives you a nice solid material to like drive screws or something into, put lighting or other things on the wall that you can then surface mount instead of having to have holes punched in the wall for like can lighting. I want to avoid that, of punching any holes that are, except for maybe the outlets and the HVAC ducts. So back to this green glue stuff. It acts as constrained layer dampening between, in my case, it would be between the sheetrock and the plywood on the outer surface. And while it doesn't change the resonant frequency, maybe a little bit from the extra mass, because the mass is what really lowers the resonant frequency. And it's why using concrete backer board and plywood instead of 2 layers of sheetrock lowers the resonant frequency so much. But by using something like green glue, that gives an elastomer layer between the 2 sheets that are the outer surface. And when the sheet tries to resonate, it turns that energy into heat, which then dampens that resonance. And that's what they're doing in this system with these wall damp viscous squares that they're putting 1 foot apart across the whole wall, so that again it looks like this when they're building the wall. It's got these little squares just everywhere. And the green glue is going to basically be doing this same sort of thing. And when I look at the cost to use these wall damp squares, that's $2,000. When I look at green glue, which is $450 for a 5-gallon pail, I would need 3 of these. So it's $1,500 for this versus $2,000 for these. And then you'd still need these strips around the perimeter. And so, still on the fence about this. I'm not sure whether that makes sense, but we're going to talk through that. It may be better off just to put those 3 layers on the wall and be happy with what we've got as far as a higher mass wall that's going to dampen the low frequencies. And that's the whole deal we're trying to do here by adding mass to the wall, is to get the low frequency under control using the walls and the construction. And then one other thing they're going to be doing is the ceiling's not going to be a flat ceiling. It's going to be sloped. And on the equipment end of the room, it's going to be approximately 9-ish feet. That isn't written in stone yet, so don't quote me. But let's say it's 9 feet at one end and it's 11 feet at the other. So there's going to be at least a 2-foot slope in the ceiling, which they said would knock down at least 12 to 15 dBs off the low frequency resonance. And they were even saying if you had to choose between like using one of these wall systems and sloping the ceiling, they said just nail 1/2-inch sheetrock to the wall and slope the ceiling is going to give you a better result than using one of these IsoWall systems and a flat ceiling. So they were really insistent about that they don't like any parallel walls, but given that the ceiling is the largest panel in the room, they said that sloping that wall is going to make a huge difference, where angling the walls in would have less of an effect, and it isn't going to be as visually strange. If you had the side walls tapering in a foot on each side from one end of the room to the other, where it was 2 feet narrower at the equipment end than the back wall, that would just visually be weird, I think. And it would limit where you can put the speakers in the room and that sort of thing. So basically that's kind of where we're at right now. And I'm waiting for them to run some simulations on the new room sizes and figure out like if this 3-layer wall makes sense. And yeah, we'll be doing another video about that in the future. And the last thing I want to show you real quick is this AMROC room mode calculator. And I don't understand a lot of stuff that's going on in this program, but I'm going to show you just a couple of examples of when you start changing the room, what happens. So there's this thing called a bolt area, and you can say it's a nice way to find room ratios when computers weren't around. And this guy kind of figured out that if you run these calculations and it ends up inside this bolt area, that it's generally going to be a room that's going to be treatable. Doesn't mean it's going to be fantastic, but that's just kind of a general rule of thumb. So here's the kind of generic size that I'm thinking the room is going to be. And again, I mentioned the ceiling's not going to be flat, so this isn't taking that into consideration. But 10-foot ceiling, 15 feet wide, 22 feet long. Okay? When you start making the room deeper, so if it ends up being even 24 feet long, we're still good here. But this little screen here, I believe, is showing you how spread out the nodes are in the room. And I believe this kind of stair step like this is good, and the more of these the better, so that when you come down to like there, that seems to be a little better, and you're getting more in the center of the bolt area. When you go down to 20, look how much it jumps going from there to there, and that's 1 foot. So that's how crazy this stuff is. The other thing is most houses have an 8-foot ceiling. So when you start lowering the ceiling height, there's 9 feet. It's heading towards the edge of that bolt area. When you get to 8 feet, it's off the chart. And look how whacked out this is. And that's why in these larger size rooms, a tall ceiling is mandatory. Now you can shrink the room size down, and you get down to a 12 by 17 or so. That's a good size room for an 8-foot ceiling. And that's what my current room is. But the problem is this Schroeder frequency gets higher, which is not a good thing. And these smaller rooms become more and more difficult to control the low frequencies. And so going up to this larger size room, go back to this dropped 40 hertz. And again, don't know a ton about this. This is something that's just fun to play with and just kind of see if your room is in the ballpark or if it's way out of whack. And you know, the ones that are the wrong shape or size and stuff like that can be the ones that are the most difficult to treat. So I just wanted to show you that real quick. And this looks like a great place to wrap up this video. Well, I hope you found all that as interesting as I did, especially that room calculator. That's just really amazing to me how important the dimensions of the room are. And while that doesn't take everything into consideration, I think that it gives you a good idea if you're heading in the right direction or if you've got a room that's just a train wreck with how it's laid out. And obviously there's things you can do to, make rooms usable that may not be ideal. But one of the key things that I keep reading over and over is that larger rooms deal with low frequencies better. And it really does make sense when you consider the length of the lower frequency waves, what they're dealing with and how to avoid having standing waves in the room. And once you get a room to a certain size, though, you also got to have a ceiling height that works with that size room, or you also have problems. A good friend of mine has a pretty large listening room in his downstairs kind of basement area, but the ceiling's only like 7 feet high. And so that's really going to limit the sonics of that room having a ceiling that low. And transversely, you get these rooms that have these super high vaulted ceilings, and that can be equally bad. That stuff just starts bouncing around in those angled ceiling areas and echoes and just other bad stuff going on. So I do feel like that, the closer you can stick to something that's in that bolt area and then has the nodes spread out evenly throughout the room where they're not stacking up, is going to make a better sounding room that's going to be easier to treat. And it may not end up needing any room treatment other than some furniture and some like canvas pictures on the walls and rugs on the floor and that sort of thing to sound really good. And so that's something to think about, especially if you're buying a house and you are considering that you want to have one of the rooms a listening room. Having that calculator to look at, and you can put the dimensions in and go, yeah, this room that's got the 10-foot ceiling, that's 15 by 20 room, is going to work nice for this and not have to build a dedicated room. And unfortunately, all the larger rooms in my house have low ceilings, and they're just really never going to be a really great space for listening to music. So that's where we're at, and I hope you're enjoying this content. It's a little different than our typical tube amplifier stuff, but it's all about getting good sound and get this room done. We're going to have a great place for really effectively reviewing equipment where I know the room's not coloring the sound, which hasn't been the case in the past. And it's really limited the kind of speakers that I could use and that sort of thing. So this is all exciting stuff to me, and hope you're excited to watch this content. Thank you for supporting the channel by watching the videos, by subscribing. If you haven't subscribed, please subscribe. Thanks to all you Patreon supporters, members, people that have supported the channel in other ways. I appreciate all you guys. Until the next video, have a nice day.